Hey Super Scientists, we're looking at your Water Science EOG Review Guide, and we're going to start out with properties of water. So water is referred to as the universal solvent, and that's because it dissolves lots of stuff. And you can think about some different things that dissolve in water, like Kool-Aid, sugar, salt. So water is the universal solvent because it dissolves most things. Cohesion has your stem co in it, which means together. So cohesion, water molecules stick together. And an example of that would be like the drops of water on a penny lab that we did. So I'm going to put penny lab. So as we put the drops of water on the penny, then it made this little dome because the water molecules were sticking to one another. Adhesion, your stem ad, means next to. So water sticks to things that it is next to, things that it is in contact with, like water on a mirror after you take a shower, or water droplets on a blade of grass. Polarity just means, or water being a polar molecule refers to water having positive and negative areas. So your little Mickey Mouse molecule of water, you have your positive hydrogens and your negative oxygen. So that'll help you to visualize polarity a little bit better. So water is polar molecule because it has positive and negative areas. So polarity causes all water's properties. So all the unique properties that we're talking about right now, those are all caused by or initiated by water being polar. The density is referring to if something is less dense, then it's going to float. Something is more dense, then it is going to sink. So if something that is more dense than water is placed in water, then it will sink. And the density of water is 1 gram per centimeter cubed. So if you put something in water that density is less than 1, then it's going to float. If you put something in water that density is greater than 1, then it's going to sink. Buoyancy is just the ability to float. And buoys that bob up and down in the ocean record data like temperature and salinity, so that may be something you've heard of before. Specific heat. So if something has low specific heat, then it's going to heat up fast. For example, metals. If something has high specific heat, it's going to heat up slowly, like water. So water in the ocean is going to stay warm even at night because it has a high specific heat, so it takes a long time for it to heat up, but then it retains that warmth. Capillary action is adhesion and cohesion working at the same time. So that is going to be moving through small tubes like within a straw or in celery or plants in general, the xylem and phloem, so it's small tubes. So I'll just put a little star and put small tubes. And one way that you can remember that is it has the word capillary in it, and your capillaries are your teeny tiny little blood vessels. Surface tension, water molecules pulling on one another. Water strider bug is able to sit on the surface of the water because of surface tension. And with the drops of water on a penny lab, you had that doming shape. So you got your penny, you had kind of that dome shape because the water molecules were sticking together, and it also created kind of like a film basically on the surface of that dome. And you could even see like the pennies, the water on the penny kind of sloshed back and forth, and it stayed together. That's because of the surface tension. So the water on Earth, of all the water on the Earth, 97% is salt water that's in the ocean. And so that means 100 minus 97 is 3. So 3% of all the water on Earth is fresh water. So where is most of that fresh water going to be stored? Well, let's take a look. So if you look at this pie chart, you can see this dark gray area. That is representing the majority of the fresh water on Earth. So that's 76%. 76% of all the water on Earth is ice. It is frozen. Ice polar ice caps, glaciers, it's frozen. And the second greatest amount, 23%, is going to be groundwater. So that's your groundwater right here. And then that tiny little sliver is going to be lakes, the atmosphere, like water vapor in the clouds, that kind of thing. So most of the fresh water on Earth is going to be ice. It is frozen. And that's not talking about teeny tiny little ice cubes that is in your drink. That's talking about big, huge glaciers and icebergs and that kind of thing. So don't get that confused with available drinking water. Available drinking water is mostly going to be stored underground. So I'm going to put a little line beside the groundwater and put that that is available drinking water. So water that's available for you for drinking water, for cleaning, for cooking, for everything that we use water for. Then currents. Surface currents are going to be at the surface of the ocean. They're going to be affected by winds. So the surface currents are going to be related to weather. So if you have warm surface current, then that's going to mean that the air above it is going to be warmer. If you have a cold surface current like it's down at the poles, then that's going to cause you to have cooler air masses, cooler air above it. Deep currents are going to be caused by density. And that's going to help to circulate water throughout the globe. So the warmer water from the equator gets carried or pushed around towards the poles where it's going to cool down, and the density is going to increase as it cools down, and that causes it to sink. And that's just going to circulate water around the Earth. So upwelling is not necessarily a current, but it's related to the movement of water. So upwelling is going to be when cold water goes up, and that's because the warm water gets blown out of the way by the wind. So the cold water moves up, and then that means nutrients get pushed up as well. And that's because the upwelling is going to be taking place at the Nitrates zone in the area where you have the continental slope meeting the continental shelf. And the effect that upwelling is going to have in the Nitrates zone, just put a little star with neritic. So the effect that that is going to have is that it's going to cause an increase in aquatic life. So it causes an increase in the population of the aquatic life that's going to be up at the surface where you have the upwelling taking place. So it's basically you're going to have cold water that gets pushed upward, nutrients get pushed upward, and then you're going to have the little fishies that swim upward too because all the food's been pushed up. Your groups of ocean life. Benthos organisms are going to live at the bottom of the ocean. For example, benthic organisms include crabs, octopods, isopods. Plankton are going to be at the surface, and they float on the waves. So wherever the waves are moving around or pushing stuff is where the plankton are going to be. And examples of plankton are going to be algae and some baby animals. So some things like jellyfish, when they're really small, may be considered plankton because they just kind of float around with the waves, and then as they get larger, then they are considered nekton because then they can move around. So the nekton group is going to be kind of in the middle, and those organisms can move up and down throughout the water column. So anytime you see the term water column, it's talking about up and down. It's talking about being able to swim or move around up and down. And examples of nekton are going to be things like dolphins and sharks, jellyfish, sea turtles, that kind of thing. Lots of fish. Different types of water. So water is either going to be considered fresh water, which means no salt, and that's going to be stored in lakes, streams, rivers, ice, groundwater. Or water that is at an estuary is going to be considered brackish. and that is B-R-A-C-K-I-S-H, brackish. So brackish water is a mixture of salt and fresh water. Brackish water in an estuary can increase if you have evaporation, because if you have a lot of heat, then that's going to cause the water to evaporate, but that leaves the salt still in the water. It does not evaporate the salt, just the water. And you can have a decrease in the salinity in an estuary if you have an addition of a lot of fresh water. So I'm going to put flooding. So the salinity in an estuary can decrease if you've got a lot of flooding, because that means you're adding more fresh water. So it's basically diluting the water in the estuary. Marine water is just referring to salt water. Your stem mar means sea. So marine water is going to be salt water. So it's going to be found in the ocean. And most of the salt is sodium chloride, NaCl. Sodium chloride, and that's going to be from the weathering of rocks and from volcanic eruptions. So I'm just going to put volcanoes. So volcanic eruptions and rocks like halite are going to break down, dissolve, and that will allow for that salt to get mixed into the water. Your different ocean zones. Intertidal zone is going to be at the beach. It's the first zone. It's where you have the high tide to the low tide area. Organisms that you might find at the beach are crabs, which can burrow down into the ground. You might have little tide pools where you have different types of things like anemones. Lots of little types of crustaceans. In the neritic zone, that's going to be the area from the low tide line across the continental shelf. So basically over the continental shelf. And that's the area where it's gradually just getting a little bit deeper. And you'll have coral reefs. Those are specifically the warm water coral reefs that are found in shallow water. And kelp forests. So those are some things that are habitats within the neritic zone. And again, you also have upwelling taking place in the neritic zone. And then the Oceanic Zone, the open ocean zone, that's the largest and the deepest zone, and it's from the continental slope, where it drops off like a big ski slope, out through the rest of the ocean. And the easy way to remember the ocean zones in their order is I-N-O, I-N-O-S-T-D. I-N-O, S-T-D. I-N-O, S-T-D. Haha, see, that's funny. So that's the surface, transition, and deep zones. So the surface zone, you're going to have sunlight, so you can have lots of nutrients because of photosynthesis. So you got lots of algae. So sunlight and nutrients, algae. The transition zone is where it's going to get colder and darker. And then the deep zone, it's of course the deepest, and it's going to have no light. So you've got organisms that are bioluminescent. And a lot of decomposers in the deep zone as well. Pollution. So some different sources of pollution, non-point and point source pollution. Non-point source pollution is where you don't know where the pollution is coming from, and it could be multiple sources as well. Examples, runoff. Runoff is always going to be non-point source pollution. And you can have agricultural runoff, which is from farms. You can have urban, just to give you another example, which is from cities. So that agricultural runoff from farms, I just put agri, A-G-R-I, your STEM, to abbreviate the agricultural. So if it's from farms, it may have pesticides, it may have fertilizer. If it's urban runoff from a city, it may have oil in it from cars. And then point source pollution is going to be where you know where it's coming from. Know where it is coming from. So you can tell where it originated. So oil pouring out of a ship. that's an example. Water quality, your different water quality indicators. Anytime you have a question that's asking you about the health or unhealthiness of water, it's referring to your water quality indicators. So temperature, the amount of heat. So if it's colder water, then that's going to be good because it can hold more dissolved oxygen. Warmer water is not going to be able to hold as much dissolved oxygen. DO, dissolved oxygen, oxygen in the water, and that can get in the water from photosynthesis. So as a byproduct of, I'll just put algae. So it's a byproduct of photosynthesis, and also from the air. Some of it can dissolve into the water from the air. That's why it's called dissolved oxygen. High DO is good. Too low is bad. And that can cause fish kills. So if there's not enough dissolved oxygen in the water, then that means fishies aren't going to be able to breathe. So they're going to die. pH is referring to the amount of acidity. The acidity level for water is going to be neutral. That means it's not an acid and it's not alkaline, it's not a base. Too high or too low is going to be bad. And normal water, neutral water should be 7. So healthy water should have a pH of 7. Nitrates. So nitrates are going to be things that can come from fertilizer or waste. You may have higher amounts of nitrates that are near places with using a lot of fertilizer, like farms. Golf courses are another example, somewhere you might have a lot of fertilizer. So if you have too much plant growth, if you've got too much of nitrates in the water, then that can lead to eutrophication, which could be an algae bloom, and that can cause low dissolved oxygen, and again, fish kills. So if you have eutrophication taking place, if you've got too much algae, that's due to a lot of nitrates being dumped into the water or from runoff, agricultural runoff from farms, for example, that's going to cause low dissolved oxygen and fish kills. Fish kills are where lots of fish die in the same area at about the same time. Turbidity is the clearness of the water, the measure of the clearness of water. If it's dirty water, if it is green from having too much algae or brown from having too much sediment in it, that's bad. And that is going to be unhealthy water. So if it's dirty water, brown, green, high turbidity, then it's unhealthy. You can test turbidity with a Secchi disc. S-E-C-C-H-I, Secchi disc. And then bioindicators are going to be living organisms that can tell you about the health of the water. So they depend on specific conditions to survive. Salamanders are bioindicators because they can't tolerate pollution. They're pollution intolerant. So if you find salamanders in a water source or around a river, like the Broad River, for example, we have lots of salamanders. That indicates that the water is pretty good. If you have E. coli, that's a bacteria in the water, then that's not good, because if you drink that water, then chances are you're gonna get sick. You're gonna have some diarrhea. DDT, dichloro, diphenyl, trichloroethane, DDT. So DDT is a chemical, and it was used as a pesticide. So your stem pest is referring to insects. So it was a pesticide applied to crops, and it ended up getting into the soil and into water. It's banned. And it caused cancer in a lot of people. So it was a carcinogen. And it also killed a lot of birds, and that was the first indicator where scientists and people knew something was wrong, because there were a lot of birds randomly dying. So that was due to the exposure of DDT. So you may see questions or pictures that are asking you about biomagnification. That's going to be referring to chemicals getting in the water and accumulating up the trophic levels. A lot of times biomagnification is going to be referring to DDT, chemicals like DDT. So you have an increase in the amount. If you can see the numbers here on your little chart, you've got an increase in the amount, so the parts per million, the concentration of DDT as you go up in the trophic level. So you can see that number is getting larger, 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 10 million parts per million in the concentration at the top, because this bird ate the fish ate the small fish ate the zooplankton ate the producers, and the producers, the phytoplankton, were just living in the water. So it accumulated and got larger as you go up in the trophic level. So the greatest amount of DDT is going to be up here with the birds in this example. And then different technology that's used to explore the ocean or to monitor the hydrosphere. Sonar is just going to bounce sound waves off the ocean floor to determine the depth. So you have a little boat and sitting there in the ocean, and it basically just bounces the sound waves off the ocean floor, and then it comes back to the ship, and however long it takes to return to the ship, scientists know if it takes a really long time, that's really deep, or if it goes ping, then it's really quick and it's a really shallow area. Submersibles, ROVs, remotely operated vehicles, are robotic vehicles. They're robots that are used to explore the ocean. And then buoys we were talking about earlier just float around in the water, and it collects data like temperature and salinity.